Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from LG AI Research K-EXAONE, Journey to Frontier-Level Performance of Foundation Models. K-EXAONE is LG AI Research's new frontier-scale language model. It uses a mixture of experts architecture with 236 billion total parameters, but only about 23 billion are active for each token, making it both large and efficient. The model is built as a sovereign, industrial-grade foundation model for Korea, but it's competitive globally. It handles extremely long contexts up to 256,000 tokens and supports 6 languages. The team evaluates it across reasoning, tool use, coding, Korean-specific tasks, multilingual benchmarks, and safety, aiming for a balanced, real-world capable system. The backdrop for K-EXAONE is the global race in large language models. Closed-source frontier models still lead, but open-weight systems are rapidly closing the gap by scaling to hundreds of billions of parameters. In South Korea, progress has been constrained by limited AI-specialized data centers and chips. So, most prior models stayed in the tens of billions range. To close this gap, the Korean government launched a strategic program to provide large-scale compute. LG AI Research used this opportunity to build K-EXAONE as a sovereign, frontier-level model that can stand alongside global leaders. K-EXAONE brings several key advances together. Architecturally, it adopts a modern mixture of experts design with careful routing and stability tricks. It uses a hybrid attention scheme to support very long contexts, up to 256,000 tokens, without exploding memory costs. The tokenizer and data pipeline are redesigned to support more languages and technical domains. Training is staged, large-scale pre-training, explicit context length extension, reinforcement learning with verifiable rewards, and a final preference alignment phase. Finally, the team evaluates not just generic benchmarks, but also Korean-centric knowledge and a new safety benchmark tailored to Korean society. Let's zoom in on the model itself. K-EXAONE uses a fine-grained, sparse mixture of experts design with 128 experts. For each token, a router selects the top 8 experts plus 1 shared expert, so 9 experts are active at a time. That gives a total capacity of 236 billion parameters, but only about 23 billion are actually used per token, which keeps inference efficient. The transformer has 48 layers and mixes global attention with sliding window attention to handle long sequences. On top of that, there's a separate multi-token prediction block that helps the model predict future tokens more efficiently and speeds up decoding. Several design choices are aimed at making such a large MoE model actually train and run reliably. The very first block is a dense feed-forward layer instead of MoE, which stabilizes early training. Routing across experts uses sequence-level load balancing so that experts are used evenly, and a dropless routing policy ensures no token is discarded due to capacity limits, which helps gradients flow smoothly. For attention, the model uses QK normalization to keep attention logits under control and applies rotary positional embeddings only to the sliding window layers. This combination improves long context extrapolation. Finally, the sliding window is just 128 tokens, which dramatically reduces KV cache memory while still capturing local structure. K-EXAONE's long context ability comes from a hybrid attention design. Some layers use full global attention, while others use sliding window attention. This mix keeps memory and compute manageable, while still allowing information to flow across the entire sequence. The model is first pre-trained with an 8K token context, then extended in 2 stages, from 8K to 32K, and then from 32K to 256K. During these stages, the team carefully adjusts the data mixture and repeatedly runs needle-in-a-haystack tests to check whether the model can still retrieve small pieces of information buried in very long inputs. Training continues until the model reliably passes these tests at each target length. To support more languages and technical domains, K-EXAONE uses a redesigned tokenizer. The vocabulary grows from 100,000 to 150,000 tokens. About a fifth of these are Super BPE superword tokens, which pack common multi-word sequences into single tokens. This reduces sequence length and improves efficiency. The tokenizer is tuned for 6 languages: Korean, English, German, Spanish, Japanese, and Vietnamese. And it also allocates capacity for STEM and code. The pre-tokenization rules and Unicode normalization are updated to better handle line breaks, superword boundaries, and symbol-heavy text, such as equations and source code. Under the hood, K-EXAONE is trained on about 11 trillion tokens using a three-stage curriculum. The team reuses and extends the EXAONE 4.0 data pipeline, adding high-quality text for German, Japanese, and Vietnamese, and balancing language distributions with targeted synthetic data. Training is done natively in FP8 precision, using the muon optimizer and a warm-up stable decay learning rate schedule. This setup keeps training stable while reducing memory and compute costs. On top of standard text, the team generates reasoning-augmented data, document-grounded chains of thought that explicitly encodes step-by-step inference, which helps later reasoning performance. Extending context length without breaking the model is tricky. K-EXAONE does this in two explicit stages. In both stages, a rehearsal dataset made of high-quality, short-context samples is mixed in, so the model doesn't forget how to handle normal-length inputs. At the same time, a synthetic reasoning dataset with challenging math, science, and programming problems is included to keep reasoning strong even as sequences get longer. Finally, a long document dataset feeds entire documents, tens or hundreds of thousands of tokens, into the model without truncation. This forces the model to learn genuine long-range dependencies, not just extrapolate from short sequences. After pre-training, K-EXAONE goes through several post-training stages. First, supervised fine-tuning teaches the model to follow a wide variety of instructions, including Korean-specific tasks built from public and institutional data. Next, reinforcement learning focuses on domains where answers can be checked: math, coding, STEM, and some instruction-following tasks. The team uses an Agapio-style objective with off-policy gradients and truncated importance sampling, plus verifiers that are either rule-based or LLM judges. Finally, a preference learning stage called Grouper refines the model's behavior using group-wise advantages over multiple sampled responses per prompt. This step aims to preserve strong reasoning while improving general alignment, safety, and conversational quality. K-EXAONE is also trained to act as an agent that can call tools and browse the web. Instead of building massive real-world environments, the team uses LLMs to synthesize tool use scenarios along with verifiable pass criteria. They then filter out unrealistic or unsolvable cases, ending up with hundreds of high-quality tasks. For web search, K-EXAONE acts as the main agent but is supported by two sub-agents: a summarizer that condenses noisy web pages, and a trajectory compressor that periodically compresses long tool call histories into a compact JSON record. All of these agents are powered by the same underlying model, which keeps behavior consistent and improves context efficiency. On evaluation, K-EXAONE is tested across 8 broad categories: world knowledge, math, coding, agentic tool use, instruction following, Korean, multilinguality, and safety. A model is consistently competitive with other large open-weight mixture of experts models of similar or larger size, and it substantially improves over EXAONE 4.0 in many areas. The overall profile is balanced. It doesn't just excel in one niche, but shows strong reasoning, solid coding and agentic abilities, robust Korean and multilingual performance, and high safety scores. Looking at detailed reasoning and coding benchmarks, K-EXAONE performs strongly. On world knowledge and academic reasoning, it scores around the mid-80s on MMLU Pro and close to 80 on GPQA Diamond. In math, it reaches over 90% on AIME 2025 and high 80s on HMMT November 2025, often surpassing other open-weight baselines. For coding, it scores about 81% on Live Codebench V6 and is competitive on the more challenging Live Codebench Pro. On agentic coding tasks that simulate real software workflows, it reaches 29 on Terminal Bench 2.0 and nearly 50 on SWE Bench Verified, indicating practical potential for code maintenance and bug fixing. K-EXAONE supports both a reasoning mode and a non-reasoning mode. In reasoning mode, it performs very well on instruction-following benchmarks, with scores in the high 60s on IF Bench and close to 90 on IF Eval. For long context understanding, it achieves solid results on AALCR and OpenAI MRCR, showing that the 256K context is not just the theoretical limit. The non-reasoning mode is lighter and faster, intended for everyday tasks where deep chain of thought isn't needed. Even in this mode, the model maintains strong long context and safety performance, making it a practical option when latency or cost is a concern. A central goal of K-EXAONE is strong Korean and multilingual performance. On Korean benchmarks, the model scores well across professional knowledge, advanced linguistic tasks, cultural understanding, Olympiad-level math, and long context comprehension. For multilingual evaluation, it achieves about 86% on MMMLU across Korean, German, Spanish, and Japanese in reasoning mode. On the WMT24++ translation benchmark, it reaches an average score of around 90.5 across 5 non-English languages, including Vietnamese. Importantly, the improvements over K-EXAONE 4.0 are spread fairly evenly across languages, suggesting a balanced multilingual capability rather than overfitting to a single dominant language. Beyond competitive programming, the team wanted to know how well K-EXAONE supports real-world coding workflows. They built Code Utility Bench, a benchmark that covers understanding, implementation, refinement, and maintenance tasks. Things like explaining code, updating it, debugging, refactoring, and writing tests. On this benchmark, K-EXAONE reaches about 72% overall, a clear improvement over K-EXAONE 4.0's 63%. The biggest gains are in understanding and implementation, showing that the model is better at reading and writing code in context. There's still room to grow in long-term maintenance tasks, but the results already point to a more capable coding assistant. Safety for a Korean sovereign model can't rely only on Western-centric taxonomies. The team introduces K-EXAONE, the Korea Augmented Universal Taxonomy, which blends global ethical principles with Korean legal, historical, and cultural specifics. It defines 4 domains: universal human values, social safety, Korean sensitivity, and future risk, broken down into 226 detailed risk areas, each with strict judgment criteria. On top of this, they build KGC Safety, a 2,260 example benchmark that includes naive and adversarial prompts, multi-turn interactions, and multilingual cases. An LLM judge evaluates whether each model response is safe, and performance is reported as the fraction of safe responses. On safety benchmarks, K-EXAONE performs very well. On Wild Jailbreak, which probes models with a wide range of harmful prompts, it achieves safe rates around 90% in both reasoning and non-reasoning modes. On KGC Safety, the Korean Global Civic Safety Benchmark, it reaches about 96% safe rate, clearly ahead of K-EXAONE 4.0 and several strong open models. The model is particularly strong in the Korean sensitivity and future risk domains, where many other systems struggle. Importantly, these safety gains do not come at the cost of large drops in reasoning or coding performance, suggesting that careful alignment can improve safety and capability together. Despite its strengths, K-EXAONE shares the limitations of all current large language models. It can still produce biased or inappropriate content, and it may generate answers that are syntactically fluent but factually wrong. Its knowledge is limited to what it has seen during training and may not reflect the latest events or laws. Safety mechanisms and benchmarks reduce risk but cannot guarantee perfect behavior. LG AI research emphasizes that users are responsible for using the model ethically, in line with legal requirements and the company's AI ethics principles, and should not attempt to use it for harmful or malicious purposes. K-EXAONE is released under a specific LG license rather than a standard open-source license. Users can download, modify, and create derivative models, but commercial distribution or making those derivatives available to third parties requires a separate agreement with LG. The license also includes ethical use clauses and restrictions on illegal or harmful applications. While LG retains rights to the model itself, it does not claim ownership over the outputs. Those belong to the users. However, users are responsible for ensuring that their use of the outputs complies with laws and respects the rights of others. K-EXAONE shows that a frontier-scale mixture of experts language model can be built and aligned outside of the usual big tech players. It combines efficient scaling, very long context windows, and strong reasoning with deep support for Korean and multiple other languages. Its performance across reasoning, coding, agentic tool use, and safety benchmarks is competitive with similarly sized open-weight models, and it introduces new infrastructure for Korean-centric safety evaluation. Overall, K-EXAONE is a concrete step towards sovereign, high-end AI systems that can serve both local needs and global applications.